All right, good afternoon, Precalculus CP. This is A4. This is May 28th, Thursday. I hope you're having a great day and a great afternoon so far. For the seniors, this is our last pre-calc class together, as I was just saying before we started recording. I don't want to get too sentimental now. We'll save that till the end. But I do want to thank you for all your hard work, and we're going to try to end on a positive note here with solving trig equations. Couple quick reminders. Number one, I did already send out, as a little courtesy for the seniors, the progress assessment on solving trig equations. So if you I did already get a couple submissions, a couple seniors that already have done it, and I appreciate you taking advantage of that opportunity. But what was I going to say? Oh, but if you are so inclined, you can get it done right after this class and call it a day for pre-calc for the people that are seniors anyway. But for everybody else, it is due on Sunday, May 31st. It is the last assessment that seniors will be responsible for. For juniors, we will have one more progress assessment next week at the end of the week, and then we'll call it a day for pre-calc as well. But for the seniors, this is just about the end, so let's end it off. Let's end it off well. What I'd like to do with you guys today is I would like to solve some more trig equations with you. Specifically, I'd like to go through the practice problems that I posted on Google Classroom with you. I'll go through all of them. I didn't post the answer key for the reason that I was like, it's probably a good idea to go through those problems together with everybody just to make sure we're all on the same page and make sure we all understand that. For anyone entering into calculus or any other math classes next year, trig equations is very important. Typically, the trig equations in calculus work out to be equal to the unit circle values, so you are just able to make use of your nice unit circle, and I would recommend having your unit circle on hand if you're planning on taking a math class in college. Not saying you're going to be a math major, but just saying a lot of majors, be it science, business, anything computer related, engineering, it'll all involve taking a math class, most likely calculus. So I would definitely keep your pre-calc notes handy. I wouldn't throw them away or burn them. Not that you would do that anyway, but I'm just saying. Because it will be useful. And these trig equations will be a topic that you will definitely be using when you get to college. If you have an equation that says the sine of x is equal to 1/2, you better know what values on the unit circle have a sine value of 1/2. That should be pretty automatic at this point. So without any further ado, let's actually talk about some trig equations, and then we will call it a day. I have 6 trig equations for you, some of which we done last class, but I think are still beneficial to go over again. So let's start by working in degrees. We're going to solve for 0 is less than or equal to x, which is less than 360 degrees. That means we're trying to find solutions on the circle in degree mode, not in radian mode. And let's start with this example of 4 times the sine of x is equal to 3. Okay, basic equation like that. What I want to do with a problem like this is exactly what I would do in an Algebra 1 setting. Think of if you had 4x is equal to 3 in a class like Algebra 1. Well, what would you do first? The first thing you would probably do is isolate the variable. So that's what we're going to do here. I'm going to divide both sides by 4, giving us that the sine of x is equal to 3/4. Now, that's obviously not a nice, pretty unit circle value, so we want to make sure that we identify where the sine is equal to 3/4. Notice we have the sine of x equal to a positive quantity. We know that sine, being that it represents y, is positive in the first and second quadrants, negative in the third and fourth quadrants, right? So that tells us that it gives us like the objectives. The objectives are, it tells us that we need to find an angle in quadrant 1 and we need to find an angle in quadrant 2 that satisfies that equation, because I have the sine of some quantity equals 3/4. Okay, the sine of some angle equals a positive value, and sine is positive in first quadrant and second quadrant, so that's why we need first quadrant, second quadrant. Now we turn to the calculator, which my calculator is right over here, and I say the sine inverse of 3/4. I press enter, and that's equal to 48.59 degrees, which is great. That's in the first quadrant, so I'm happy with that, 48.59 degrees. And now we can use that first quadrant angle to get the measurement for my second quadrant angle. You may recall that if you have an angle in the first quadrant, these are our reference angles that we discussed. Any angle in the second quadrant that shares the same sine and cosine values, maybe positive or negative might be switched around, but it's 180 degrees minus theta. To get an angle in the third quadrant that matches up, it's 180 degrees plus theta. And to get something in the fourth quadrant that matches up, it's 360 degrees minus theta. That's how we were finding our reference angles around the unit circle earlier. So all I do with that quadrant 1 angle is I just say, well, we also need something in quadrant 2. So I'm going to do 180 minus my 48.59, and I get, bang, 131.41. Just like that. And so our two solutions for x are 48.59 degrees and 131.41 degrees, because both of those would have a sine value of 3/4. Does that make sense to everybody? Hopefully. Doing great. I take your silence as yes, Mr. Giorgio. Everything is fantastic, which is fantastic for me. So let's move on. Next one. Ready? We have 8 is equal to 9 times the cosine of x. Let's do plus 3. I know the one on the worksheet says plus 2, but I'm pretty sure we did the plus 2 yesterday. So we'll just, or last class. I keep saying yesterday, Tuesday. So let's change it up a little bit. Plus 3 instead. Just like Algebra 1, if I had 8 equals 9x plus 3, I would isolate the variable first, subtract the 3 over to this side. I get 5 is equal to 9 times the cosine of x. Divide both sides by 9, and you get 5/9 is equal to the cosine of x. Now I pause for a moment and I say, ooh, the cosine of an angle is equal to a positive quantity. Where is cosine positive? Well, going back to our little diagram here, we know cosine representing x is positive in the first and the fourth quadrant, not in the second or third, because x being positive means we're going to the right. So that means that my objectives are I want to get an angle from quadrant 1, I want to get an angle from quadrant 4. Let's see what our calculator tells us. We turn to the calculator, I do the cosine inverse of 5/9, and I get 56.25, which is great. That's in quadrant 1. Nice. That satisfies that, makes me happy there. Now I need to find my quadrant 4 angle. In order to do that, I reference the diagram up here, and I say, ooh, the matching angle in quadrant 4 is going to be 360 minus my 56.25, which is, let's find out, 360 minus 56.25, and it comes out to be 303.75 degrees. And so those are your two possible values for x that satisfy the equation. Not too bad, right? Pretty simple so far. All right, fantastic. Let's do a tangent example. We didn't do a tangent example last class. I think it's good to talk about the tangent, of course. Let's see if we have an equation like 2 times the tangent of x plus 3 is equal to 1. Okay? Now, before we even get started, we know that the tangent of x is positive because tangent represents slope. Tangent represents sine divided by cosine. Tangent is positive in the first quadrant because both sine and cosine are positive. So positive divided by positive is going to equal positive. It's also positive in the third quadrant because negative sine divided by negative cosine is going to equal a positive tangent. Represents slope. Anything going like this would have a positive slope, right? Any line running from the third quadrant to the first quadrant. It's also negative in quadrant 2 and negative in quadrant 4 because in quadrant 2 only the sign is positive, so positive divided by negative is negative. And in quadrant 4 the cosine is only positive, the sign's negative. Negative divided by positive is still negative. So now that I established that for tangent, we can go ahead and solve my equation. Isolate the variables, subtract 3 from both sides, you get 2 times the tangent of x is equal to negative 2. Divide both sides by 2, and you get that the tangent of x is equal to negative 1. Now, this just so happens to be a special unit circle case, but even if it wasn't, I would say, ooh, the tangent is equal to something that's negative. That means we need an answer in quadrant 2, and we need an answer in quadrant 4, because that's where the tangent is negative. Well, let's see what the calculator is going to tell us here. I'm going to do the tangent inverse of negative 1, and it tells us that it's at negative 45. Rats. Rats. Although that's good, that is true, it's not within our 0 to 360 range, right? So I get that the tangent inverse of negative 1 is negative 45 degrees. But we can recognize the fact that negative 45 degrees is going to have the same tangent value, just with its sign swapped around, as positive 45 degrees, right? That's going to have the same exact tangent value. It's just going to be a positive one instead of a negative one. So we can use this reference angle, that's what it's called, reference angle, like we talked about before. We can use this reference angle in the first quadrant to find our quadrant 2 answer and our quadrant 4 answer. Okay? So what I can do is I can say, well, the quadrant 2 answer is going to be 180 degrees minus 45, which is 135. And our quadrant 4 is going to be 360 minus 45, which is what, 315? Like that. And so I get two answers here of 135 and 315. Okie doke. Which, again, just so happens to be our special unit circle angles. You could look on your unit circle and notice, ooh, 315 degrees is going to be negative 1 for the tangent value, because it's this divided by this. And this is also going to be negative 1 for the tangent value, 135. But does that make sense? Another way that you could have tackled that, by the way, is you could have noticed, ooh, negative 45 degrees, which is going to be like right about here in the fourth quadrant, is coterminal with, just add 360 to it, 315 degrees, right? So you could have added 360 to go all the way around the circle from negative 45. You would have ended up at 315. And then you can go ahead and find the angle that's directly across from it by just subtracting 180. So that's another way that you could have actually approached that problem. I always like resorting to finding the first quadrant, because once you have the first quadrant, you can just go ahead with any of your other options. It's very easy. If you go ahead with the coterminal approach, that's fine too, but it requires a little bit more critical thinking about the unit circle. So do it if you want a challenge, but I always like going with the first quadrant. Any questions so far? Nothing? Well then, let's talk radians. Let's talk radians. Ready? Instead of solving for 0 to 360 degrees, let's talk about our radians. Let's go from 0 to 2 pi. Okay, let's go from 0 to 2 pi. All right. Let's do a problem like this. If I have 8 times the cosine of x plus 1 is equal to 5. And I'd like to solve that equation. What I want to do is, just like algebra 1, isolate the variable. I get 8 times the cosine of x is equal to 4. Divide both sides by 8. You get that the cosine of x is 4 over 8, which reduces to 1/2. Now, we know where the cosine of x is 1/2. That's a special unit circle value. That's 60 degrees. But just in case you didn't know that that was the case, we can go ahead and use our handy-dandy calculator. Before we do, let's recognize the fact that the cosine is equal to a positive quantity, meaning we're looking for an answer in quadrant 1, and we're looking for an answer in quadrant 4, because the cosine is positive in quadrants 1 and 4. Right? Positive, positive, negative, negative. That's cosine. So let's see what our calculator tells us. If we do the cosine inverse of 1/2, notice I kept my calculator in degree mode. It tells me that it's 60 degrees, but since we're working in radians, we know that 60 degrees is the same as pi over 3, right? So we know that x is pi over 3. And now, how do we find this matching angle in quadrant 4? Well, since we're working in radians instead of working in degrees, it just slightly changes the values here. They're still equivalent. If I have an angle in the first quadrant, to find something in the second quadrant that matches up, I'm going to do 180 degrees, or pi if we're working in radians, minus theta. I'm going to do 180 degrees, or pi in radians, plus theta. And here I'm going to do 2 pi minus theta, because 2 pi is equivalent to 360. So to find something in quadrant 4, I'm going to say, ooh, well, I have my first quadrant angle. I'm going to do 2 pi minus pi over 3. If we find a common denominator for 2 pi, that's going to be 6 pi over 3 minus 1 pi over 3, which is, of course, equal to 5 pi over 3. And so those would be your two answers. Okay, and that is verified by the unit circle. If you take a look quickly at the unit circle, you could see that, ooh, pi over 3 has cosine of 1/2, and 5 pi over 3 cosine of 1/2. Okay. Any questions about that at all? Okay. This next one's a cool one. I like this one a lot. We have 6 times the tangent of x is equal to negative 3 times the square root of 3. Okay? I like this one a lot. So how do we solve this? Well, what I would do, again, algebra 1, divide both sides by 6 to get my variable alone. I have the tangent of x is equal to negative rad 3 over 2. That's how that would reduce, right? 3 divided by 6 reduced to 1/2. Now, rad 3 over 2 is not a special unit circle value, right? That's not, we have rad 3 over 3. That's a nice unit circle value. But rad 3 over 2 for tangent is nothing. It's just a random value. So what I'm going to do, that doesn't mean we can't solve it. We just have to go through our normal process. What I'm going to do is I'm going to change my calculator to radian mode, because we're going to get decimals. We're not going to get exact values like pi over 2 is an exact value, pi over 6 is an exact value. We're going to get decimals. So since the tangent is equal to a negative quantity, that means I'm looking for something in quadrant 2, and I'm looking for something in quadrant 4, because that's where tangent's negative. Let's see what this tells us. We're going to get the tangent inverse of negative rad 3 over 2. Pop up. And I get negative 0.71. Well, negative 0.71 is in your fourth quadrant, right? Just like how if we got a negative degree measure, that would be in the fourth quadrant. This is also in the fourth quadrant, this negative 0.71, right? We can go ahead and move it to the first quadrant, though, to say, well, this value of the tangent inverse of negative rad 3 over 2, giving us negative 0.71, that it has a reference angle in the first quadrant as positive 0.71. That's going to have the same tangent value, just with an opposite sign. It's going to be positive, right? The reason, again, for that, the reason why we know that this is in the fourth quadrant is because tangent, the tangent inverse function, like I showed that very first day, only operates in the fourth quadrant and first quadrant, just like the sine inverse function does. Now that I have that, I can go ahead and use this and just find my angles around the circle. The quadrant 2 angle is going to be pi minus 0.71, which is, again, I'm going to have to resort to my calculator here. We got pi minus 0.71. We get 2.43 radians. Just because it's a decimal doesn't mean it's illogical or doesn't make sense. It works just as well as anything else. And for quadrant 4, I'm going to do 2 pi minus my 0.71. And we get 5.57 radians. So this is 2 pi minus 0.71. Gives me my 5.57 radians. Okay. Again, not exact fractions like pi over 2 and pi over 3 and 5 pi over 6, but those are still radian values that exist on the unit circle. Okie doke. Remember, this is our quadrant 4. This is our quadrant 1. All right, last problem. Let's do it. Let's make it a good one. This is what we did last class, but I think it's definitely worth going over again. We have 5 times the sine of x minus 3 is equal to 6 times the sine of x minus 2. It's a quick one to end with, but it's an important one to show what happens if you have sine in 2 spots. It doesn't mean we panic. It doesn't mean we freak out. It doesn't mean we cry. We just say, think about algebra 1. If this were 5x minus 3 equals 6x minus 2, you would get all the variables on one side. You'd get all the constants on the other side. That's exactly what I'm going to do here. Move 5 sine of x over here. I'm going to add 2 to move that over here. I get that negative 1 is equal to the sine of x. And we know that what angle is going to have a sine value of negative 1? That's going to be your quadrantal angle of 3 pi over 2. Right? Now, if you didn't know that from the unit circle, you could say, well, let's put our calculator back in degree mode. Watch, and you'll see why I do that in a minute. If I did the sine inverse of negative 1, you're going to get negative 90 degrees. Well, negative 90 degrees is straight down. What angle in radians matches up with that? We know that that's 3 pi over 2. Notice if I kept my calculator in radian mode, and I did that, if I did the sine inverse of negative 1, I get this decimal, and that decimal is, if I add 2 pi, go all the way around the circle, that is the same as 3 pi over 2. So if I did 3 pi over 2. It should be the same exact decimal, but that's really hard to see. That's really hard to notice. So I recommend always using degree mode if you notice you're going to be on a nice unit circle angle. Otherwise, you're going to get these decimals, and you're going to have to be like, I don't really know what those decimals mean. It's harder to link the decimals together with the actual unit circle angles. But if you use degree mode and you see negative 90, you're like, oh, that's the same as 270 because you add 360 to it, which is the same as 3 pi over 2. Alrighty? So, just a quick little recap. What we did today is we just went over some more basic trig equations, some of the same ones we did last class, which I think were worth taking another look at. But just to make sure that you understand how to do these, we establish our objectives. Once we do our Algebra 1 processes here to get down to sine of x equals something, cosine of x equals something, tangent of x equals something, we establish our goals and say, well, sine is equal to a positive quantity, so I know we're looking for quadrants 1 and 2. Cosine equal to a positive, looking for 1 and 4. Tangent equal to a negative, we're looking for 2 and 4. Right? If this were negative 5/9, then we'd be looking in quadrants 2 and 3 instead. Okie doke. Once you do that, you can use our calculator to get the value in the first quadrant and then apply this idea of reference angles to get those other quadrants. Same thing if you're working in radians, you're just going to be working with pi and 2 pi rather than 180 and 360. All right. And that's it, pre-calc. For seniors in here, I'm going to miss you guys, to be very honest. But I'm going to thank you. I want to thank you for being fantastic students this year. I want to thank you for your hard work and dedication in pre-calc. I know that at times the class is demanding and difficult. It is by design. Hopefully you can reflect back on it and realize that you came out a little better at the end. But I hope I was able to make it as good of an experience as I could for you. I, again, really appreciate having you in class and the hard work that you've done. Again, I don't want to get too sentimental because the juniors are still around for next week. But for the seniors, I want to wish you best of luck. You are always free to contact me with any questions or concerns that you may have in the future. I hope that we cross paths again. I hope to see you at the class reunion, which is scheduled in November. But otherwise, you know how to find me if you need me. And for everybody, I hope you have a fantastic day. I hope you have a fantastic weekend. Remember the PA that is due on Sunday. Even for seniors, you still have to do that. Make sure you do it. But everybody else, thanks everyone for everything you've done this year in pre-calc. We have one more week to get through, juniors. We can do it. We can do it together. Everyone take care. Have a great day and a great weekend. I will see you guys next time.
Thank you. You too, Mr. Giorgio.
See you guys.
Bye, Mr. Giorgio.
Thank you guys. See you later.
Have a good one, Mr. Giorgio.
Later, Michael.